to pass through the fiber. Now see, if I give light through a fiber, and we expect that it will go to the other end without any problem. Does it happen? No.
Sir, আমাদের স্যার রেকর্ডিং এর পারমিশনটা যদি দিতেন স্যার, মানে পরবর্তীতে স্টাডি করতে স্যার এটা একটু ইজি হয় স্যার, মানে পরীক্ষার আগে বিশেষ করে এটা অনেক কাজে লাগে স্যার।
বাট ওকে, get it. Okay.
স্যার আমাকে সাইদ ভাই আপনি একটু রেকর্ড করেন, আমি এই যে ফোন থেকে কানেক্ট হইছি তো আমার এখানে কারেন্ট চলে গেছে, আপনি একটু রেকর্ড করেন সাইদ ভাই।
আরব ভাই হাত নামায় ফেলেন তাহলে।
আমি হাত নামাইতেছি।
আর কে তিনজন,
তাহলে সাইদ ভাইকে দিলেই হবে। আর শারমিন শর্মা আপু মনে কিছু বলতে চাচ্ছেন,
কি বলো, কে বলতে চাও বলো।
মিনিমাম 2 জন রেকর্ড করলে ভালো।
কে বলো, কে কি বলতে চাও,
কারণ একজনের এখানে টেকনিক্যাল প্রবলেম হতে পারে।
বলো।
স্যার আসসালামু আলাইকুম স্যার, আমাকেও রেকর্ডিং পারমিশনটা দিয়েন স্যার। আমি হ্যান্ড রেজ করেছি স্যার।
হ্যাঁ দাঁড়াও, দেওয়া হয়েছে না? হ্যাঁ দেওয়া হয়েছে, তোমাকে পারমিশন দেওয়া হয়েছে। হ্যাঁ, শারমিনকে পারমিশন দিবেন।
আমার
পাইনি স্যার, আমি রেকর্ড দিলে স্যার পারমিশন চাচ্ছি স্যার।
হ্যাঁ শারমিনকে দেওয়া হয়েছে তো 40।
জি স্যার।
Ask to start video. Okay. So what I'm telling, see, in the previous chapter we had been discussing something. What is something? That is the theoretical aspect, like how light propagates. That means we discussed Maxwell's theory that gives us an idea how electromagnetic wave propagates through a cylinder or cylindrical structure or waveguide. And we also have seen there are certain limitations such as total internal reflection, acceptance angle, pore cladding, refractive index ratio, and so on. That will give us a condition by using which we can expect that light will propagate through the fiber. Now, there are further considerations. If I give a light at one end of a fiber and we expect the light to reach the other end of the fiber without much of distortion, will it occur? If the fiber is like 1 meter.
স্যার আপনি স্যার ভিডিও স্টার্ট করার পারমিশন দিয়েছেন স্যার, রেকর্ডিং এর পারমিশনটা হয়নি স্যার। ওটা স্যার স্টার্ট টু আস্ক টু স্টার্ট ভিডিও আছে স্যার, রেকর্ড ইন লোকাল ফাইল দিতে হবে স্যার, ওখানে আরেকটা পারমিশন আছে সিমিলার।
allow record, that's right, okay.
জি স্যার, এটি স্যার allow record স্যার। জি স্যার, সাইদ ভাইকে আর স্যার শবনম আপুকে দিলে হবে স্যার, দুজন করলে।
রেকর্ডিং ইন প্রোগ্রেস।
এই এখন শুরু হচ্ছে স্যার।
Thank you sir.
Okay, so today we are going to discuss the transmission characteristics of the fiber, of the pale fiber. What does it discuss? What is there? In fact, in relation to our previous discussion, where we discussed the theoretical aspects, what are the conditions required for light to propagate through the fiber? There are we have seen the theoretical aspects. Now we come to actual fiber. If I give some light at one end of the fiber and we expect it to reach the other end without much of distortion, does it occur? Does the light go exactly the same light we receive at the receiving end that we give in the transmitting end? No, it does not occur in this way. So what are the things, what are the factors that causes this unintentional disruption? There are two types of factors. One is linear, one is non-linear. So among linear aspects, see these are attenuation, polarization dependent loss, chromatic dispersion, group velocity dispersion, and dispersion slope and higher order, that means this is part of chromatic dispersion as well. Then polarization mode dispersion, including higher order PMD. So 1, 2, 3, 4, 5, 4 or 5 types of factors or issues that has to be dealt with, that has to be considered while we think about the propagation of light through an optical fiber. These are the linear parameters. What is linear? What is non-linear? Hello? Hello?
Sir,
Hello?
linear means straight line, and non-linear
Yes,
means pizza.
এই লাইট অন, তোমার ভিডিও অন করো, কে কথা বলো, সাথে সাথে ভিডিও অন করো। হ্যালো, ভিডিও অন করো। কে রোল কত কথা বলছিল? হ্যালো হ্যালো,
স্যার আমার একটু স্যার
কথা বলছিল কে?
স্যার আমি বলছিলাম আমার পিসিটা একটু হ্যাং হয়ে গেছে স্যার, অপশনটা আসতেছে না।
Anyone else can define what is linear and non-linear? Hello, it's a very basic term. It's a basic. You can say mathematical term or basic physical term.
স্যার লিনিয়ার হয় যখন হচ্ছে একটা ভ্যারিয়েবলের সাথে আরেকটা ভ্যারিয়েবল স্যার ডিরেক্টলি প্রপোর্শনাল হয়। আর নন লিনিয়ার হচ্ছে স্যার যেমন কোয়াড্রেটিক ইকুয়েশন একটা নন লিনিয়ার গ্রাফ।
Give some example.
নন লিনিয়ার গ্রাফ হতে পারে সিগন্যালস, যেরকম স্যার
এক্সাম্পল বলো, সিগন্যালস বলতে বুঝতে পারছি না, একটা লিনিয়ার এন্ড নন লিনিয়ার এক্সাম্পল বলো।
স্যার লিনিয়ার হচ্ছে এরকম y = mx + c, একটা স্ট্রেট লাইন।
বাস্তব
আচ্ছা
বাস্তব ক্ষেত্রে, হ্যাঁ বাস্তব জীবনের একটা উদাহরণ দাও। কি কি নাই বাস্তব জীবনে
মাথায় আসতেছে না।
মাথায় আসছে না।
আমি বলবো?
হ্যাঁ বলো
স্যার কারেন্ট মানে আই
ভিডিও অন করো বিনতে।
স্যার ফোনের মধ্যে অপশনটা পাচ্ছি না স্যার।
হোয়াট ইজ দিস? আই ডোন্ট আন্ডারস্ট্যান্ড। একজনে হ্যাং করে, একজনে অপশন পায় না। হোয়াট ইজ দিস? এই বয়সে তোমরা এগুলো কি বলো?
স্যার আই প্রপোর্শনাল টু ভি মানে কারেন্ট বাড়লে ভোল্টেজটা বাড়বে, ওহমস ল। এটা হচ্ছে লিনিয়ারের এক্সাম্পল।
জি।
আর স্যার নন লিনিয়ার স্যার অনেকটাই হইতে পারে। এটাতে হচ্ছে ভেরিয়েবল গুলা যেহেতু মানে প্রপোর্শনাল টু না, গ্রাফটাও অনেকটা মানে স্ট্রেট লাইন না হয়ে বিভিন্ন শার্পের হইতে পারে, সাইন এক্স, কস এক্স।
অঙ্কের দিকে যাও কেন, জীবনের দিকে যাও। জীবনের একটা এক্সাম্পল দাও। ধরো তোমার শাড়ি কিনলা, ঈদের সময় 5টা শাড়ি, একই রকম শাড়ি, 5টা কিনলা 5 চায়ের জন্য বা 5 রিলেটিভের জন্য। একটার দাম যদি 100 টাকা হয়, একটা দাম যদি 1000 টাকা হয়, 5টার দাম হবে কত? হ্যালো
স্যার 5টার দাম 500 হবে স্যার। একটা শাড়ির দাম 100 টাকা হলে 5টা শাড়ি 500 টাকা হবে স্যার।
কি সমস্যা?
100 টাকা দামের কোনো শাড়ি আছে?
বিনতে শুনতে পাচ্ছ? তুমি মাইক অফ করো, করে কথা বলো। হ্যাঁ মাইক অন করো, হ্যাঁ কথা বলো। মানে
জি স্যার। হ্যালো,
তোমার বাস্তব জীবনের অভিজ্ঞতা, বাস্তব জীবনের উদাহরণ হলো এই শাড়ি। ধরো তুমি 5 জনের জন্য 5টা শাড়ি কিনলা, একই রকম শাড়ি কিনলে। একটার দাম যদি 1000 টাকা হয়, 5টার দাম কত হবে?
স্যার 5000 টাকা।
10টার দাম কত হবে?
10,000 টাকা।
এক্স্যাক্টলি, যতগুলা কিনবা তত ইনটু 1000, এটা হলো লিনিয়ার ইকুয়েশন, লিনিয়ার ইফেক্টের একটা এক্সাম্পল। আর যদি ধরো মানুষের অসুখ, ধরো মানুষ দেখো বয়সের সাথে কিন্তু অসুখ বেড়ে যায়। ধরো যখন মানুষের বয়স 50, 60, 70, 80 হয়, তখন দেখবা যে এইটা সেটা ওইটা কমপ্লেক্সিটি অনেক অসুখ বেড়ে যায়, তাই না? মানে এটা বয়স বাড়ার সাথে সাথে প্রথম 30 বছর যেরকম অসুখ বিসুখ থাকে, তারপরে 30 বছর একটু বাড়ে, তারপরে 30 বছর একদম দেখবা যে র্যাপিড অসুখ বিসুখ বেড়ে যায়। এই যে বেড়ে যাওয়াটা, এটাই হলো তোমার এক ধরনের নন লিনিয়ার ইফেক্ট, নন লিনিয়ার ফেনোমেনা। যদি আমরা কারেন্টের সাথে যাই, তাহলে দেখা যাবে যে ডায়োডের মধ্যে দিয়ে যে কারেন্ট ফ্লো হয়, যদি ভোল্টেজ আমরা বাড়াতে থাকি 0.7 এর বেশি গেলেই ওর মধ্যে দিয়ে প্রচুর কারেন্ট ফ্লো হয়, এর আগ পর্যন্ত কারেন্ট ফ্লোটা কম হয়। এইটা যে এই যে কারেন্ট ফ্লোটা একটা ডায়োডের মধ্যে দিয়ে, সেটা হলো নন লিনিয়ার। বাট একটা রেজিস্টরের মধ্যে দিয়ে কারেন্ট ফ্লোটা হলো লিনিয়ার। যদি 1 ভোল্ট হয়, যে কারেন্ট যাবে 2 ভোল্ট হলে তার দ্বিগুণ কারেন্ট যাবে, 3 ভোল্ট হলে তার 3 গুণ যাবে, 10 ভোল্ট দিলে তার 10 গুণ কারেন্ট ফ্লো হবে। দ্যাট মিনস একটা রেজিস্টরের মধ্যে দিয়ে যে কারেন্ট ফ্লো হয়, দ্যাট ইজ লিনিয়ার। বাট একটা ডায়োডের মধ্যে দিয়ে যে কারেন্ট ফ্লো হয়, দ্যাট ইজ নন লিনিয়ার। আমাদের প্রাত্যহিক জীবনে আমরা এভাবে দেখি যে তোমার ওই যে চক্রবৃদ্ধি সুদ আছে না, সেটাও নন লিনিয়ার। চক্রবৃদ্ধি সুদটা হলো নন লিনিয়ার, আর সরল সুদটা হলো লিনিয়ার। সো আমাদের এখানেও আমরা দেখি যে লিনিয়ার ইফেক্টটা হলো সেই ইফেক্ট, সেই ধরনের ইফেক্ট গুলো যেগুলো ডিস্টেন্সের সাথে বাড়ে, প্রপোর্শনালি বাড়ে, একই হারে বাড়ে। ওকে, যেটা ডিস্টেন্সের সাথে একই হারে বাড়ে। যদি 10 কিলোমিটারের মধ্যে যতটুকু অ্যাটেনুয়েশন হবে, 20 কিলোমিটার হলে তার দ্বিগুণ অ্যাটেনুয়েশন হবে। যদি 100 কিলোমিটার হয়, তাহলে তার 10 গুণ অ্যাটেনুয়েশন হবে। দ্যাট মিনস with the increase of distance, the attenuation will be directly proportional. So that is your linear effect. So এইভাবে আমরা what is now see first comes a linear attenuation. Introductory কথা যেটা আমরা we have been discussing so long. The most important part in a fiber is that you cannot give bandwidth or data whatever you want. I mean, you have to give some limited bandwidth based on its capacity. What is that capacity? This capacity is limited by these parameters, by linear and non-linear effects. First comes attenuation. What is attenuation? Attenuation is আমরা বাংলায় বলি যে ক্ষয় হয়ে যাওয়া। So as distance is increased, the power or energy of the inducted signal is being reduced. So why it happens? It happens because of the interaction between the molecules and the light itself. Okay, that causes this attenuation. And there are other molecules or impurities in the fiber that causes this this collision, this and resulting in attenuation. So if there is a term, normally it is expressed in dB, decibel. This power, this attenuation is normally we say 0.2 dB per kilometer. What was 1000 dB per kilometer initial days, now it is only 0.2 dB per kilometer. Very, very low. So, and it is expressed in dB. The equation for dB will be 10 log P1 by PO. PO is the received output power. PI is the input power. So input power by output power, if we made the log of that, base 10 multiplied by 10, that means 10 log 10 PI by PO, P input by P output. That gives us a decibel of the loss or attenuation. and see this dBl. Another term is dBl. If L is 1 kilometer, so this is dB per kilometer. Now it is normally always in decibel, and it is proportionate with the distance. See, there is a math, important math is given. You can easily find out the parameters like 8 kilometer length, then 120 microwatt. What is the optical power? At the power output is 3 microwatt. So 120 microwatt is input, 3 microwatt is output. Length is 8 kilometer. So from this you have to find out some parameter, some problem like the overall signal attenuation koto hobe, then attenuation per kilometer koto hobe. Then if that distance is 10 kilometer, then what will be the loss? And so it is very simple. Then easily put the values in this equation and easily find out the values. And since there is 8 kilometer, for 8 kilometer attenuation is 16 dB, what will be the dB per kilometer divided by 8? Because for 8 kilometer, 16 dB, 1 kilometer, 2 dB, 2 dB per kilometer. So you can solve it easily. Okay. There is one important terminology like dB and dBm. There. dB and dBm. What is dBm? Milliwatt. So for milliwatt, the unit will be, you have to add more 30 because it is milliwatt. Reference is used as milliwatt. Okay. I come here. See here, this reference is PO, and PO is in terms of watt. This is in watt, this is in watt. If the output power is measured in terms of milliwatt, then there will be 30, a term 10 to the power minus 3 will come. 10 to the minus 3, if it comes in the up, it will be 30. Ultimately, 3 into 10, 30. So 30 will be added. If you say, if you convert it into dBm, then you have to add more 30. See, here it is, in dB it is 60. If it would have been dBm, it would have been 46. Can anyone explain how it will become 46? It is in dB. Signal attenuation in dB, it will be 16 dB. If it is dBm, this would have been 46 dBm. dBm. Can anyone explain how it is? Hello? He? Can you explain how for dB it is 16 dB, for dBm it will be 46 dBm. Can anyone?
স্যার আমরা যদি মানে পাওয়ারটা মানে ক্যালকুলেশন করি যে ডিবি তে, তাহলে হচ্ছে আমাদের ভ্যালুটা আসে 10 লগ টি অ্যাকচুয়ালি। তো ওইটার সাথে যদি আমরা ডিবিএম এ মানে মিলিতে নিয়ে যাই, মিলিওয়াটে নিয়ে যাই, তাহলে হচ্ছে আমাদের ডিবি থেকে ডিবিএম এ কনভার্ট করতে গেলে আমাদের মূল যে পাওয়ারটা, ওই পাওয়ারের সাথে 30 প্লাস করা লাগে। যার কারণে স্যার এখানে হচ্ছে, তো এইখানে স্যার 10 লগ 1040 10 লগ 1040 প্লাস হচ্ছে 30।
ওই 30টা কোথা থেকে আসে?
স্যার মিলির ক্ষেত্রে স্যার আমি এরকম করছিলাম স্যার, মিলিতে কনভার্ট করতে গেলে স্যার হচ্ছে 30 প্লাস করা লাগে আর কি, এটা জানতাম।
ওরে বাবা, ঠিক আছে, তো বাট এটা বুঝতে তো হবে জিনিসটা কিভাবে আসে, সেটা বুঝতে হবে, তাই না?
জি স্যার। স্যার কি আর
ওটাই বলতে চাচ্ছি,
একটু ক্লিয়ার করে দিলে ভালো হতো স্যার। জি স্যার।
Can anyone explain how dB and dBm there is a difference of 30? Okay, let me clarify. Okay, আমরা এখানে আমাদের কি আছে? এই পিওটা কিসে? ইট ইজ ইন টার্মস অফ আউটপুট পাওয়ারটা হলো ইন টার্মস অফ ওয়াট। ওকে, এই এটাকে আমরা যখন মিলিওয়াটে রেফারেন্স হিসেবে নিব, আউটপুটটাকে যখন মিলিওয়াটে নিব, তখন এটা কি হয়ে যাবে? সামথিং যাই হোক এখানে ওয়াট ইন্টু 10⁻³ হয়ে যাবে না, মিলিওয়াট যেহেতু। সো এটা যদি এখন 1 ওয়াট থাকে, এটা হয়ে যাবে 10⁻³ এত ওয়াট, এত মিলিওয়াট হয়ে যাবে। সো এই মিলিওয়াট হওয়ার কারণে 10⁻³ আসবে। এই -3টা যখন নিচে থাকে, এটা উপরে যদি নিয়ে আসি আমি, তাহলে কি হয়ে যাবে? 10⁻³ হয়ে যাবে না? 10⁻³ হয়ে যাবে। যেহেতু লগ লগ এবং মাল্টিপ্লিকেশন, তাহলে এটা প্লাস হয়ে যাবে না? 10 log 10, আর এই 10 টু দি পাওয়ার এটা হয়ে যাবে 3। 3 হওয়ার কারণে এটা হবে log 10 into 3 হয়ে যাবে। 30 হয়ে যাবে। সো thereby that means এটার ইউনিটটা হলো মিলিওয়াটে, সেজন্য এই মিলিওয়াটে নিলেই এটা 10⁻³ হয়ে যাবে। হ্যাঁ, ওই 3 হওয়ার কারণে এই 30 will come. ওকে, বিভিন্ন তোমার ইয়েতে কি বলে, বিভিন্ন ভাইবেটে বেতে এটা জিজ্ঞাসা করতে নরমালি করে বা করা হয় এট টাইমস, যে হোয়াট ইজ দ্য ডিফারেন্স বিটুইন ডিবি এন্ড ডিবিএম। হাউ you say that plus 30, then it will become dBm. So where from this 30 will come? If you answer that the reference is milliwatt, that is why it is from that it will come 3 10⁻³, and that will to take the log of that, it will become 3, and it is decibel, so multiplied by 3, it will become multiplied by 10, so this will become 3 into 10, ultimately 30. Okay, now see, there are other parameters, linear parameters, that is the material absorption losses in silica glass fibers. So there are two types. So there is absorption. The main word is the absorption. So material absorption is a loss mechanism related to the material composition and the fabrication process of the fiber, which results in the dissipation of some of the transmitted optical power as heat in the waveguide. The absorption of light may be intrinsic or extrinsic. So the thing is that when the light passes, there are some absorption. The absorption can due to the material composition and fabrication process. এই দুইটার মেকানিজমের কারণে there are some absorption. This absorption occurs or causes the wave to be absorbed, and the result is heat. When the light is absorbed, it gives out some heat. So light is absorbed and some heat is produced. Heat is not expected, but it is produced inside the fiber, and that is the material absorption. And this material absorption, again, there are two types. One is intrinsic, one is extrinsic. What is intrinsic? Intrinsic means নিজস্ব, as it says, is its own. And absolutely pure silica glass has little intrinsic absorption due to its basic material structure in the near infrared region. Total intrinsic absorption is formed due to the effects of infrared absorption, ultraviolet absorption, Rayleigh scattering, as shown in this figure. So there are some types of again, intrinsic absorption is also having some segments or some other compositions. What is that? See, if this is attenuation dB per kilometer, this vertical scale, and this is the electron volt energy, if you say that, then see, this is ultraviolet ray absorption. So that means when your electron volt is up to around 1 volt, so it is the minimum. And when it is around 2 volt, this absorption is maximum. Again, see, this line is the infrared absorption. So it starts from 0.8 electron volt, it goes up to around 0.5 or so, and it is a sharp rise. As the photon energy increases, this absorption also increases. Now, see the Rayleigh scattering, see the dotted line. This one is a Rayleigh scattering. This also has got a almost a chronological or almost linear slope that the attenuation decreases with the increase of the attenuation decreases with the decrease of photon energy. That means when it is 2 is a maximum, when the electron volt or photon energy is minimum, like for 0.6, the absorption is also minimum. Now see, the aggregated one is this one, the total. This ultraviolet ray absorption, infrared absorption, Rayleigh scattering absorption, all those are aggregated, and we get this one, this thick line. Okay, so it shows us that there is a minimum absorption at somewhere here, 0.8 electron volt, when it is photon energy, when it is around 0.8 electron volt. At that time, the absorption is the minimum. Okay, this one, this window. Then extrinsic absorption. Okay, what is that? Because there are some foreign particles other than your this intrinsic material, like OH, hydroxyl ion in the glass material, that will cause you this extrinsic absorptions. Okay, like see at wavelength 2.7 to 4.2 micrometer, that is one of the area where you will have maximum absorption. And there are other materials, like see, this is a graphical representation of the attenuation. See, here is one of the peak, third overtone, second overtone is here, and the highest absorption is in the range of 1300 to 1400 nanometers. This is the wavelength of the light. Okay, so it is giving us, so when light passes through the glass waveguide, it faces some foreign or external materials like hydroxyl ion, and due to the collision of light and that ion material or external material, this extrinsic attenuation occurs, and its pattern at which wavelength is maximum minimum, that is a figure showing this graph. So this measured attenuation spectrum of ultra low loss single mode fiber, that means the solid line. This is the solid line. It is showing from different losses. So see, this is the waveguide imperfection, this absorption, the bottom one. This is the ultraviolet absorption. This is infrared absorption. This is Rayleigh scattering absorption. So as we have seen earlier, so all those absorptions are total, and this is the graph is showing that what is the absorption comes up, right? The resultant absorption. And so the maximum absorption is one peak is there at around 1400 nanometers or 1.4 micrometers. Now, linear scattering losses. What is linear scattering losses? Scattering, the term by scattering, we understand that when something is not going as per focus, it is going out of the focal point. So that means deviations from the central line of axis. That is the scattering. Now, and due to how this scattering occurs, what causes the scattering? Linear scattering mechanism causes the transfer of some or all of the optical fiber contained within one propagation mode to be transferred linearly, that is proportional to the mode power, into different modes. We have seen there are different modes. So when the light from one mode shifts to another mode, then that is termed as one of the linear scattering. Due to linear scattering, this can occur. That means the power from one mode can be transferred to another mode. So what happens? This process tends to result in attenuation of the transmitted light as per the transfer, as the transfer may be leaky or radiation mode, which does not continue to propagate within the fiber core, but is radiated from the fiber. Okay, so that means when you are transmitting the light in a particular mode, if it is drifted, if it is shifted to another mode, so you do not exactly if some of the energy is going to another mode, then that means your original mode or actual mode, some of the energy is not available. That means some of the energy is missing. So that causes this absorption. Okay. That is ultimately overall energy is reduced. That is part of this linear scattering loss. This scattering loss are mainly two types: Rayleigh and Mie scattering. So what are those? Rayleigh scattering. So Rayleigh scattering is the dominant intrinsic loss mechanism in the low absorption window between the ultraviolet and infrared absorption trails. It results from where? From inhomogeneities of a random nature occurring on a small scale compared to the wavelength of the light. Okay. So this is an important terminology. That means the inhomogeneities of a random nature, but it is a small scale compared to the wavelength of the light. That means wavelength data 1400 nanometer, 1500 nanometer. So if this inhomogeneities that is also compared to that wavelength, then this Rayleigh scattering will occur. And there is a relation of this Rayleigh scattering coefficient that is giving 8 pi square by 3 lambda square. See here, this lambda is mainly the variable. T, K, beta C, P, N, almost all are almost constant for a fiber. On this lambda will be varying. Now what this means, this the gamma R is the Rayleigh scattering coefficient, lambda is the optical wavelength, N is the refractive index of the medium, P is the average photoelastic coefficient. It is fixed for any particular material. Then beta C is the isothermal compressibility at a fictive temperature. This is, if temperature is fixed, then this value also fixed. Then K is the Boltzmann constant. This is also fixed figure. And okay, and TF is the temperature. TF is the temperature. Okay, so it sees that it is found that only this lambda, it is the main variable which will determine the value of Rayleigh scattering coefficient. That means lambda R. And for a particular distance, it can be measured in this way. Okay, then exactly the basing on that formula, there are some values are given and problem is solved here. Now the other term is the scattering. Earlier it was the inhomogeneities are compared to the wavelength, and here is linear scattering may occur in inhomogeneities which are comparable in size with the guided wavelength. So it is now that is smaller in size, and this is comparable. So again, this can also cause the irregularities at the core cladding interface. Okay, this can be caused due to the inhomogeneities, the core cladding junction points. Okay. Then comes some nonlinear scattering losses. Linear scattering loss, nonlinear scattering losses. Okay. For nonlinear scattering losses, we have stimulated below-in scattering, and stimulated SBS and SRS, stimulated Raman scattering. আমরা একটু হালকা একটু ব্রেক নেই, তারপর আমরা আবার শুরু করি। হ্যালো,
জি স্যার।
জি স্যার।
কথা বলতে কষ্ট হয়, আর ওইদিকে মনে হয় তোমরা কেউ আসছো কি নাই। honestly if I am talking in the dark,
আসলে স্যার আপনার কথা একটু আস্তে শোনা যাচ্ছে, তো এইজন্য স্যার আমরা সবাই মিউট করি।
Out of the scattering effects, see, stimulated Raman scattering and SBS is SRS SBS. We have already discussed it earlier. Okay, scattering effects, and see different tones on Raman and below-in scatterings are shown. See WS, WP, WA, upper sideband, lower sideband, and this is frequency of scattering light. Okay, S, P, and A. What is that? See, Stokes, anti-Stokes is a Raman and below-in Raman. And it is the main frequency. Then see, they are distributed on both sides of your main frequency. Stoke, anti-Stoke, A and S, and WP is the pump frequency. Pump frequency, Stoke frequency, anti-Stoke frequency. Now the Carr effects. What is Carr effects? Carr effects is the after the name of Mr. Carr. Full name I don't know. I don't remember full name. Carr. Carr is the name of a scientist who developed this phenomena, who invented brought out this phenomena of nonlinearities. That's after his name, these Carr effects are named. This under Carr effect, there are two effects. One is cross phase modulation. One is cell phase modulation. I just want to tell you what are those parameters, those nonlinearities. Now see, when we increase light intensity beyond certain level, what happens? The refractive index of the fiber changes. I come once again. When we increase the intensity of the carrier light, then what happens? Due to this increase of the intensity of the light, the refractive index of the material changes. Now, what happens? If the refractive index of the material change, then the light passing through that fiber will also change, and there will be a shift of energy. And due to this, there will be some modulation, and additional modulation or unintended modulation. due to this unintended modulation, there will be some loss of energy, and that will give the problem of this car intensity. Normally, at shorter distance, this car nonlinearity does not create any problem. But if the length is above certain level, and also the inserted energy or transmitted energy is above a certain level, only then this car effect will become prominent. But since optical fiber is being used for long distance communication, so this car effect has to be considered, and it was once upon, it was very, very prominent problem. But nowadays, due to by using various modulation techniques and power management and your fiber profile management, by using all these aspects, this nonlinear effect, I mean, car effects are being controlled and kept to the minimum. So this propagation constant beta can be expressed beta equal to twice by n effective by lambda. Okay. See this n effective. This can be expressed the effect. This effect, that means when this nonlinear refractive index changes, and it can be expressed as n effective equal to n0 lambda, that means at a particular bandwidth, at a particular frequency, equal to n2 P2 by A effective. So P2 is the instantaneous signal power, and A effective is the fiber, the area of the fiber. A effective is the core effective area of the fiber. So core effective area and the power of the signal, and N2 is, we know the nonlinear coefficient. N2 is the nonlinear coefficient. N0 is the at a particular N0 is the particular nonlinear coefficient at a particular frequency, and N2 is the nonlinear coefficient, and that is multiplied by power of the signal divided by the your core refractive area, core area of the fiber, and that gives you the effective refractive index. And since power can be varied, or rather power changes time to time, we can, due to change of power, this nonlinear coefficient, effective nonlinear coefficient also varies. So that's thereby, if power increases, effective nonlinear coefficient also change, and this nonlinear coefficient gives rise to the effect that causes this car effect. Car effect has got two components. One is self phase modulation, one is cross phase modulation. Why you say modulation? Because the change in the refractive index, it will cause the light to slow down or pass down faster, and that will ultimately generate a new frequency, and that will be beating with the original light and giving rise to a particular modulation, and thereby it is termed as self-phase modulation or cross-phase modulation. What is self-phase modulation? We'll see this one a little later. SPM. What is self-phase modulation? Self-phase modulation is nothing but is the only one signal is present, and due to the change of the transmitted power, the same wave affects itself. Is self-phase modulation. And what is cross-phase modulation? Cross-phase modulation is this one. When there are two or more channels, now due to change of refractive index or power in one channel, it may affect your neighboring channel. So neighboring channel ki affect korle jei effect ta seta holo cross phase modulation. See, this is given here. this part A and A1. These are two channels, and they give rise to the changes the effect on A. So A1 is a neighboring channel. So neighboring channel will affect the other channel. And so one channel affecting the transmission of neighboring channel, that is the cross-phase modulation. And here is only the same channel. See, here is A, here is A, here is A, here is A, all A. That means there is no neighboring channels effect is not considered. The same channel affects itself due to change in the power level. That will change its own profile, and thereby it is called self-phase modulation. So car nonlinearity has got two: intra-channel and inter-channel. So intra-channel is again divided by two: signal to signal, signal to noise. Signal to signal gives rise to SPM, and it is can also be differentiated into isolated pulse SPM, IXPM, I4-wave mixing, and that's the intra 4-wave signal mixing. Then signal to noise again has got two types. One is SPM induced nonlinear phase noise, and one is MI. Okay, MI is the modulation instability. MI is the modulation instability. Again, inter-channel nonlinear car effect has got two types. One is signal to signal, the WDM, and signal to noise. Signal WDM, it has got again XPM, cross polarization modulation, 4-wave mixing, and signal to noise has got one effect. There's a XPM induced nonlinear phase noise. Okay, so this car nonlinearity, the total spectrum of this car nonlinearity is explained through this figure. 4-wave mixing. What is 4-wave mixing? 4-wave, when there is a mixing of beating of light at different frequencies or different wavelengths in a multi-channel fiber transmission, cause phase modulation of the channels and hence the generation of modulation sidebands at new frequencies, which are termed 4-wave mixing. That means when there are mixing of channels, mixing of or beating of two lights, it will give rise to a different frequency or different set of frequencies, and that is termed as 4-wave mixing. This is termed as, see, when three wave components co-propagate at angular frequencies omega1, omega2, omega3, then a new wave is generated at frequency omega4, where omega4 equal to omega1 plus omega2 minus omega3. So this is a new frequency. So this is due to 4-wave mixing. It's termed as 4-wave mixing. 4-wave mixing is always a phenomena which will give rise to a different frequency. Okay. Now see, this is a figure. Soliton. What is soliton? Soliton is the shape of the pulse. Okay. What type of shape? See, we know there are some basic type of signal. One is rectangular pulse, sawtooth pulse, and so on. But mainly in rectangular pulse, what happens? It is a sharp rise and sharp fall. This sharp rise and fall, it causes your generation of the other non-linear effects. But if it is gradually increased and gradually decreased, there is no sharp edge. At that time, the effect bad effects or negative effects are being reduced, and thereby see in this pulse there is the first one. There is no sharp edge. Sharp kuna nahi, kuna. So sharp edge, there is no sharp edge. And due to since there's no sharp edge, then it is free of many nonlinear effects. And this type of pulse is normally termed as solitary. So solitary is nothing but a pulse shape, which does not have any sharp changes in it. The changes are gradual, and thereby it reduces the possibility of generation of nonlinearity. Here, this equation is given for Schrodinger equation, which gives rise to the nonlinear, how to avoid nonlinear effects in a pulse shape. With this, we have come to the end of our today's class. If you have any question. Now you can switch off your recording. Hello. Now you can switch off your recording.
জি স্যার, আমি সুইচ অফ করে দিয়েছি স্যার।
Recording stopped.
Okay, done. Any question?
Okay, going to my presentation. My presentation is a bit different from the memorizing part. What we done, what I have done. Today I'm going to go very genuinely and explain how a optical communication works. That I will explain that very generally, and with that I will add some memorizing or accurate information as much as possible. Okay, let's begin. So the major driving force behind the widespread use of fiber optics communication is the high and rapidly increasing consumer and commercial demand for more and more telecommunication capacity and internet services. And advances in technology have enabled more data to pass or convey through a single optical fiber over long distances. The transmission capacity in optical communication network are significantly improving using the technologies and especially wave division multiplexing. Okay, in the next slide, this is the basic principle how a optical fiber principle communication works. Here, an optical fiber is a dielectric cylindrical wavelength made of lowless materials, usually silicon dioxide. The core of the wavelength has a reflective index a little higher than the outer medium, so that the light pulses is guided along the axis of the fiber by total internal reflection. This is the main mechanism that basically used for the optical fiber data connection system, and this is the figure I am showing. Then if we go to the next slide, we are going to experience the categories of the categories. Optical fiber fall into two major categories. That is step index optical fiber, which include single mode optical fiber and multi-mode optical fiber, and graded index optical fiber. Single mode step index optical fiber that we have learned in the previous lecture from our honorable teacher has a core diameter less than 10 microns and only allows us one light path. Multi-mode step index optical fiber has a core diameter greater than or equal to 50 micrometers and allows us several light paths. And the more interestingly and advanced is graded index optical fiber that has their own core reflection index gradually decreases further from the center of the core. What it actually does, that it increases the reflection of the core center and slows the speed of some light rays, thereby allowing all the light rays to reach the receiver almost the same times. Okay, let's go to the next slide. Going to the next slide. Now I am going to say what is a repeater. This is a very important portion because we cannot pass the data at frequently, however and how far we want, because for the attenuation there are some data loss in the cable. For that we have an amplifier or a station that actually enhance the lost power, and we can use our data further and further. And now I am giving a very clear example how we send data from our phone and it going to the other end of the world by the optical connection. Okay, so stay with me as possible. Suppose I am writing hello from my mobile phone. So what is actually it's doing? It is converting the every alphabet in ASCII code, and this ASCII code will be converted in the binary code. Suppose for H is 010011000. Then this code will create a electromagnetic wave, and this wave will be created by the highest frequency for 1 and 0 for the low frequency. Then this will be transmitted from the transmitter, and light pass will be 0 and light on will be for 1. That is how a data or the binary data is generated. Then the whole world, nothing in this world is wireless totally. The whole world is connected with the submarine connection, and global mobile operators, these are the giant operators that handle the submarine connection, that are Google, Orange, and AT&T. You might know about that. And what is actually happening in that cable? This is the intersection of the cable where there. If I can use my mouse, yes, I can use my mouse. Here there is steel wire, and it looks so complex, but main wire is passing data is passing through this portion, but other steel wire is for the strength of the cable because it is underwater or underground. And the important question is how we are passing from one part of the world to the other without any repeater. Dear my friends, this is the interesting factor. That is that we have a insulator and copper shell that is continuously holding the current and giving the signals or data a complete and stopping the attenuation. That's how without repeater we are transforming underwater. Why it is best? Because light is always faster than electrons. Light is massless, and electron that must have some mass.
You want to mean that there is no amplifier is required?
No, sir. In underwater, there is no amplifier is required because insulator and copper shell already hold the electricity. That amplifies the data flow. As far as I have learned, sir, for the presentation. So can I proceed, sir?
Proceed.
Thank you, sir. Why optical fiber is best? Optical fiber is we have to understand the main concept. We are transforming light, not any electrons, and light is always definitely there is no chance copper wire can cope up with optical fiber communication. And we have a larger bandwidth, and we can travel much further. We have high speed connection. And main fact is that when an electron passes through a wire, there is a magnetic field that causes electromagnetic interference that will enhance the power of the copper cable. That is why optical fiber is superior from any other communication system. Almost coming to the last section of my presentation, the future trends. Future trends. Optical fiber is still got some limitation. And what is that? First, going to the main era of optical fiber. Suppose presently optical fiber satellite links and orbit to ground links. That means it's not wireless. It is grounded than connection. So current research explores optical communication to and from high altitude platforms. What this means that high altitude platforms are like spaceships situated above the cloud that will be a height of 16 to 25 kilometers, where the unfavorable atmospheric impact like rain, sun, and others on a large beam is less suffer than the directly above the ground, as shown in this figure. Optical links between high amplitude platforms and satellites and ground stations are expected to serve as a broadband black hole communication channel. This is a concept channel. If a high amplitude platform function as a data relay station is possible to create. So this will be a whole new era of optical fiber communication system. And dense wave division multiplexing is a very crucial part. It is because dense wave division paves the way for multi-terabit transmission. The worldwide need for increased bandwidth ability has led to the interest in developing multi-terabit optical networks. And with the help of dense wave division multiplexing, optical fiber will be more faster and more reliable. Okay, that's all for today. That's all, sir.
Okay. Go to your first slide.
Yes, sir. Sir.
First one.
Sir.
What is the topic?
Sir, I have given a title: Optical Communication Principle, Properties, and Future Trends.
So, see, it is very difficult to understand by anyone to see what is the topic on which you are going to give presentation. In fact, just to ask anyone, I believe 99.99% student will not understand what is the topic of your presentation. Okay, and that should get at the বিউপির এত বড় মনোগ্রাম কে দেওয়া দরকার ছিল, বরং তোমার সবচেয়ে বড় দরকার ছিল তোমার টাইটেলটা, টাইটেল অফ ইউর প্রেজেন্টেশন। তুমি এত কিছু দিলে, ডিপার্টমেন্ট, এটা সেটা, হাঙ্কি ফাঙ্কি, এত কিছু, কোর্স, MICT 1204, এগুলো কি দরকার ছিল আমার সেটা বলো।
স্যার দরকার ছিল না স্যার, জাস্ট টাইটেলটা এন্ড আমার নাম আইডি দিলেই হতো স্যার।
তোমার নাম আইডি দিলেই হতো, নাম আইডিও দরকার ছিল না, অনলি নেম প্রেজেন্টেড বাই সো এন্ড সো, তারপরে প্রেজেন্টেশন অন অপটিক্যাল কমিউনিকেশন প্রিন্সিপাল, properties and future trends. That could have been enough, and you have not given a slide number, কেন? পরেরটা যাও, পরের স্লাইডে যাও, আরো যাও, হ্যাঁ আরটা যাও, হ্যাঁ। তো এই যে তুমি এইটা দিলা, হ্যাঁ, এই যে তোমার পাশাপাশি কিছু এক্সপ্রেশন থাকতে পারতো, এত বড় হেডিং কি দরকার ছিল? তোমার ফিগারটাকে ইয়ে করে এত বড় হেডিং দেওয়ার দরকার ছিল, এত বড় ফন্ট দরকার ছিল, এটা মানে অনেক বড় ফন্ট। পরেরটা যাও, যেমন এইখানে এই যে তুমি ইয়ে দিছো, দুইটা ফিগার দিয়েছো, বাট ফিগারে কোনো নাম নাই, কোনো টাইটেল নাই। ক্যাটাগরিজ সি ছোট হাতের কেন? টাইটেল সিটা বড় হাতের হতে পারতো। তোমার এই দুইটা ফিগারের টাইটেল থাকতে পারতো, তাহলে আমি কি বুঝবো এটা কি? এটা কি ভেলকিবাজের কিছু? এটা কি মানে? ইট ইজ very simple matter is that whenever you give a figure, you must give a title.
Sorry, sir. This I will add that next time.
So
I will never do the same mistake.
These are the observations. Keep in mind that your presentation should be
identical for everyone.
Should be easy for the listeners to understand.
স্যার দেখা যাচ্ছে?
যাবে